Hi, the doctor's in. I'm Dr. LB, and I'm here to help you through your math difficulties. Today, we look at what is a polynomial. A polynomial is of the form f of x equals a sub n times x to the n plus a sub n minus 1 times x to the n minus 1 plus dot 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 dot. That means it's a whole lot of terms probably between a sub 2x squared plus a sub 1x plus a sub 0, where a sub n is not 0. Here, a sub n is called the leading coefficient, and n is the degree of the polynomial. So, a sub n times x to the n, that represents the term that contains the highest power of x. So, the highest power of x here is n, that is the degree, and the coefficient associated with that is called a leading coefficient. So we need to determine if the following are polynomials. Now, polynomials have powers that are whole numbers on the variable x. So if you look at this example, you have 6x to the fifth minus 3x cubed plus 1, 5 and 3, that's a whole number. So we can say, yes, this is a polynomial function. In the next problem, we have 4x to the fourth minus 5x squared plus 2 over x. We can rewrite this as 4 times x to the fourth minus 5x squared plus 2 times x to the negative first power. Now, notice that we have a power that's not a whole number. Negative 1 is a negative integer. So we say no, this is not a polynomial. You cannot have negative powers when you're dealing with polynomials. The next one we have h of x equals 8x cubed plus pi times x squared plus 2/3 x. Is this a polynomial? We say, yes, it is. Now, pi is not a whole number, but that's okay. Your coefficient can be any real number. You can have a fraction as your coefficients here, but you just cannot have them as powers. The next example, we have x to the 1/5 minus 5x, and no, this is not a polynomial because, again, 1/5 is not a whole number. You cannot have a power as a fraction. So polynomials have smooth continuous graphs. So this first graph is a polynomial, smooth continuous graphs. This second graph is not. The second graph is not a continuous function because we go and when we draw it, we have an open circle and a closed circle down there. So this is not a continuous graph. We have to pick up our pencil to shade in this right here at 2, 1. So that's not a function, not a continuous graph. This third one is not a function because you have a sharp turn. Remember that polynomials have smooth graphs, smooth continuous graphs. So remember that Dr. LB is always in. Please come back for more math help.